In this video, we'll be taking a special integral 0 to 6 integration 36 minus x squared under the radical sign. And also we are taking the same function, but we'll integrate between 1 and 3. Let's try to understand the graph of the function. So our function is square root of 36 minus x squared, which is actually the semicircle above the x-axis. And the boundaries will be -6 to +6 because the radius of this circle is 6. All right. So when I'm taking 0 to 6, so I'm actually taking 1/4 of the integral. So 1/4 of the circle. Area of the circle, you take 1/4. So this one from high school geometry, we can easily know that this result is 1/4 pi r square, radius is 6 squared. So that gives you 9 pi, right? But we'll do this one by hand also. So let us look at the integral square root of 36 minus x squared dx. All right, so we understand that trig substitution will be good. You can say x equals 6 sine theta. So then dx will be 6 cosine theta d theta. And now apply all these known facts. 36 minus x squared, let's evaluate that. 36 minus, when you square x, you get 36 sine squared theta. When I factor out 36, I get 1 minus sine squared theta, which is basically 36 cosine squared theta, because you know the trig identity. Sine squared theta plus cosine squared theta equals 1, like this. This is well known. Sine squared theta plus cosine squared theta equals 1. So then cosine squared theta simply 1 minus sine squared theta. So then within the radical sign 36 minus x squared, I get 6 cosine theta. All right, so we plug the values. Integral square root of 36 minus x squared gives me 6 cosine theta, and dx gives me 6 cosine theta. So altogether I get 36, factor out, and then you have cosine squared theta d theta. Right? Now we need to do another substitution for cosine squared theta. We know the double angle formula. Cosine 2 theta equals 2 cosine squared theta minus 1. So from here, if you isolate cosine squared, you can see 1 plus cosine 2 theta equals 2 cosine squared theta. So definitely cosine squared theta will be 1/2 1 plus cosine 2 theta. So I'm getting 36 1/2 1 plus cosine 2 theta. Very nice integral. So you get 18, and then you are just writing 1 plus cosine 2 theta d theta. So the integral is immediate. 18 theta plus sine 2 theta over 2. So we are done with the integral. So I will take some space to simplify the result. Okay, as you remember, x equals 6 sine theta. So sine theta will be x over 6. Now look at the right triangle. When you have a theta, then you get this side is x and this is 6. So this side must be 36 minus x squared. All right. So then from here we can say my cosine theta equals adjacent over hypotenuse, which is 36 minus x squared over 6. All right. So we'll plug all these values now here. As you remember, sine 2 theta is 2 sine theta cosine theta. So when I plug it here, this 2 will cancel out with that 2. So I get 18 theta plus sine theta cosine theta. Now all the values I have ready. So my theta will be sine inverse x over 6 plus, then I will plug other values here, like sine theta is x over 6, and then cosine theta is coming out as square root of 36 minus x squared over 6. Okay, so I'm done with the integral. Now I need to take cases, the first case and the second case. The first case is integral 0 to 6, so we put the limit 0 to 6. Now as you see here, when I replace 6 for x, I get sine inverse 1. And then when I plug here 6, that goes to 0. And when I plug 0, everything goes to 0. So then you know that sine inverse 1 is pi by 2, because sine pi by 2 is 1. So you get 18 times pi over 2, that's 9 pi. As you have seen using high school geometry, we got area of the quarter of the circle, which is 9 pi. Now the second part of the problem. So let's see what happens in the second part. So we have limit 1 through 3, and we are actually getting area of this portion. In this case, high school geometry doesn't work, but our integration by substitution completely gives me the power. So when I plug 3, so you get 18, and then sine inverse 3 over 6. So 3 over 6 is 1/2, right? So you can easily find those values. When I plug here 3, so you get plus 1 over 12, and then square root of 36 minus 9. So 36 minus 9, you can easily calculate. When you plug 1, then you get sine inverse 1 over 6 with a negative sign. Sine inverse 1 over 6 plus 1 over 36 is square root of 36 minus 1, which is 35. And we got our answer. All right, thank you.